Here's a pattern I see constantly. A storage account that started cheap quietly grows into one of your top 3 line items. The fix is almost never deleting data. It's putting the right data on the right tier and letting a policy move it automatically. In this video, I'll dissect a realistic Azure Blob storage architecture, the 4 access tiers, how a lifecycle management policy moves blobs between them, where data and requests actually flow, and the failure modes that bite people in production. By the end, you'll know exactly which knobs to turn and which traps to avoid. Block blobs live in one of 4 access tiers. Hot has the highest storage cost but the lowest access cost for data you read and write constantly. Cool is cheaper to store but charges more per read with a 30-day minimum retention. Cold is cheaper still with a 90-day minimum. Archive is dirt cheap storage but the data is offline. You cannot read it directly. It has a 180-day minimum and you must rehydrate it before access. The core trade-off is simple. As storage gets cheaper, access gets more expensive and slower. Pick the tier by how often you actually touch the data, not by how important it feels. You don't move blobs by hand. You attach a lifecycle management policy to the storage account written as JSON rules. Each rule has a filter by prefix or blob index tag and a set of actions keyed off age. A typical rule reads, if the blob hasn't been modified in 30 days, move it to cool. After 90 days, move it to archive. After 365 days, delete it. You can also key on last access time, but that requires enabling access tracking, which adds a small per transaction cost. The policy engine runs roughly once a day, so movements are eventually consistent, not instant. Don't expect a blob to tear down the moment it crosses a threshold. Picture a logging and analytics pipeline. Events land in a hot container via the ingestion service, where dashboards and recent queries hit them hard. After 30 days, query frequency drops, so the policy moves them to cool, where they're still readable for the occasional investigation. After 90 days, compliance requires retention, but nobody queries them, so they go to archive. A year out, the delete action removes them entirely. The application code never changes. It always writes to the same container and same path. The tiering happens underneath, invisible to your write path. Reads from archive are the only thing that needs special handling because that data is offline. 3 traps. First, early deletion fees. If you move a blob to cool and delete it before 30 days or to archive before 180 days, you're billed as if it stayed the full minimum. Tiering churn can cost more than it saves. Second, rehydration. Pulling a blob out of archive takes hours, up to 15 for standard priority, and incurs a retrieval charge. If a user clicks download and waits, that's a broken experience, so design an async request and notify flow. Third, write amplification. Every tear down is a transaction you pay for, and small files make per transaction cost dominate. Tiering millions of tiny blobs can be a net loss. Check the current Azure docs, because these minimums and prices change. The biggest design decision is which signal triggers tiering. Last modified time is free and predictable, but it tears down data that's old yet still actively read. Last access tracking moves blobs based on real read patterns, which is smarter for unpredictable workloads, but it adds per operation overhead and a tracking cost. My rule of thumb, use last modified for append-only data like logs and backups, where age maps cleanly to value. Use last access for shared document stores or media where access is bursty and unpredictable. When in doubt, start with modified time rules, watch your access metrics, and only switch if you see costly retrievals from cooler tiers. So here's the architecture in one breath. For tiers trading storage cost against access cost and speed, a JSON lifecycle policy that moves blobs automatically based on age or access, and a set of minimum retention and rehydration rules you must design around. The trade-off an architect weighs is always churn versus savings. Your concrete first move, open your storage account, look at the largest containers, and write one lifecycle rule that moves data older than 30 days to cool. Watch the cost and access metrics for a month before adding archive. Don't tear blindly and always confirm the current minimums and pricing in the Azure docs because they shift. Get the policy right once and it pays you back forever. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.